are going to use question 1 to learn how to solve problems that involve quadratic sequences. The question 1 says the following is a quadratic sequence. So we are already told that this sequence that we are given is a quadratic sequence. We are going to break it down to check if it's a quadratic sequence or to see if it has the properties of the quadratic sequence. This is to say that I'm going to write my sequence down so that I have the first term to be a 12, the second term to be a 20, the third term to be a 30, the fourth term to be 42, and this sequence we're saying it goes on like that. We know that in a quadratic sequence we have the first difference where I'm going to say 20 minus 12, which would give me an 8. Then I would say 30 minus 20. Remember, when we look for the differences here, we actually are subtracting the successive terms, the next term minus the previous term. Then I'm also going to say 42 minus a 30, and I should get a 12 there. In a quadratic sequence, we know that we also have the second difference, which should be a constant. And here I'm going to say a 10 minus an 8, that should give me a 2. A 12 minus a 10, that should give me a 2 as well. Then I can see that this is a quadratic sequence because it tends to have a constant second difference, and it also has the first difference here, as much as there is this constant second difference. Now we can see that indeed this is a quadratic sequence. Question 1.1 says write down the next two terms of the sequence. Now this question is specific. They're saying to us that write down, not calculate or determine. And this question, it's like worth 1 mark. It means we literally have to write down the next two terms. We don't have to do long calculations using a formula. And we only want the next two terms, really. Now, to answer this question, I'm going to remove here these last 3 dots here because we're trying to extend the sequence. We are going to look at the pattern that is happening in this sequence. Remember, we said that this is an arithmetic sequence here at the bottom, and we have been finding these two by subtracting this and that, and finding these two here by subtracting the 10 and the 8 as well. And we know that in an arithmetic sequence, if we look at this alone as an arithmetic sequence, we know that if we say 8 plus 2, we get a 10. And that's how we actually have been extending the sequence to get the next term. If we take this 10 now again and we add a 2, it gives us a 12. So the pattern here, we still treat it the same way in which we did in arithmetic sequences. So that if I come here and say the 12 plus a 2, 12 plus a 2, I should be able to get a 14 in there. That means I'm going to get a 14 here. However, you have to notice as well that if we say a 12 plus the 8 here, we then get the 20. Because remember, for us to get this 8, we subtracted 20 and 12. So if we do the reverse process where we say 12 plus, it's a reverse process plus the 8, it should be the 20 because it's a reverse process. The same is true if we say this 20 plus this 10 here, we should get a 30. And if we say the 30 plus the 12, it should give us the 42. That means now for me to get a term here, I then need to say this 42 plus the 14, right? The 42 plus the 14, it should give me the next term here. Now, if we say 42 plus a 14, that should give us a 56. Yes, that's a 56. That means here I'm going to have 56 as my next term. And if we continue doing the same pattern here, we can say now again, the 14 plus a 2, right? The 14 plus a 2, and this should give me a 16. I then now take the 56 and the 16 to get the next term here. So this means I'm going to say 56 plus a 16, and that should give me a 72. That means this plus that, I should get a 72 here, and this perhaps can continue going on like that. But at least to answer our question, they only want us to do the next two terms. So that means here we're simply going to write 56 and 72. So this is very easy to do, and of course it should be done within a minute, for 1 mark, because you literally here can punch your calculator, take your calculator, add the 12 and the 2, it gives you 14. You take the 14, 42, you add and the 14, you get that 56, you write it down. Then you take the 14, you add the 2, you get a 16. Then you take that 16, you add it to 56, and then you get the 72, you write it down, and that's how you get your 1 mark. You're not necessarily doing calculations here, you're studying the pattern. All these numbers, you basically pressing them on a calculator. The 1.2 question says that determine the nth term of the sequence. Remember that the nth term is the general formula. So we want a formula that can define the sequence in general, that can assist us to find any term in that sequence. Well, we are going to use a lot of what we learned in lesson 1. The first thing that I'm going to do here is that I'm going to say the second common difference, the constant difference in an arithmetic sequence is generally given by a 2a, right? This is the second common difference, is given by 2a. And in this case, we know that second common difference to say it is a 2. So that means the 2a is going to be equal to 2. Now let's back up a little bit. I'm going to go back to our previous lesson so that we know what we're talking about here, just to remind ourselves. Remember, the properties of a quadratic sequence is that the second common difference here is given by d is equals to 2a. That's why I'm saying the 2a would be equal to the 2 in that case, because it's the second common difference. This is what we got in general here, if you remember this lesson. And that's what we are doing here. Now, in simplifying this, we can all clearly see that a is going to be equal to 1, because what we do here is that we divide by 2 on both sides, so that this side it cancels. I'm left with a, and here 2 into 1, it really goes once. Now, the second thing that we are going to do here really is to say that the first of the first difference is actually equals to 3a plus b. Again, let's back up a bit here and go back to our previous lesson, just for you to be able to see that when we listed the properties of a quadratic sequence here, the second property that we spoke about following this one here was that the first of the first difference is actually given by 3a plus b, is always given by that. We see this here. When we subtract these terms in general, we came up with this first of the first difference to be 3a plus b. Now, we know that this difference here is actually given by the 8 here. because it's the first of the first difference. Remember, we get this 8 by saying T2 minus T1. Just so maybe I write these things here at the top to assist us to be able to see what I'm talking about. We are saying here T2 minus T1, right, which is 20 minus 12, and we get an 8, right? And we're saying that this would be an 8, and we're saying that this first of the first difference will always be in general defined by 3a plus b. Now here I'm going to have an a. Well, I'm going to substitute this a because we know that a is 1. Remember, from this here we know that a is 1, and here I have a b. Now this allows me to find the b, and in fact we can quickly see the value of the b there by just looking at this equation to say b is going to be equal to a 5, because here I'm going to have a 3, and if I take the 3 this side, I'll have an 8 minus a 3, which is equals to the 5, right? Now we also said that term 1 of a quadratic sequence will always be defined by a plus b plus c. That is another property that we spoke about when we looked at the properties of quadratic sequence. In fact, it's a third property following this first property, the second property, and the last property. We said that term 1 will always be given by a plus b plus c, and is what we found here for term 1 when we were doing our sequence in this lesson 1. I remember we said those are defined in general. Now at this stage we know that term 1 in this sequence is actually a 12. Our T1 is a 12 in this specific sequence. That means here I'm going to put the 12, and we know that a is a 1. We have calculated that to be a 1, and we know that b is a 5. So I'm going to write my 5 here, and c we don't know. Now immediately also here one can see that the value of c would actually be equal to 6. Why? Because here I'm going to have 1 plus 5, which gives me a 6. I take the 6 to this side, then I'm having a 12 minus a 6. That should give me a 6, right? And I'm left only with a c on this side, which is that. Now at this stage we are going to take our general equation for the quadratic sequence, which is an squared plus bn plus c, and we simply just plug in the values of a, b, and c. Because we know that a is 1, that means here I'm going to have n squared, because the 1 here, if you put the 1 here, it will just multiply this. Remember, any number multiplied by 1 is that number. But here we are going to actually have the 5n, sorry, because remember b is a 5. If I put a 5 here, then I'm going to have 5n, and the c we're simply saying that it's a 6. And this would then be our nth term. This would be our general formula as the question requested. It would be our nth term. This question is marked 4 marks. So that means here you will get a mark for finding the value of a, finding the value of b, finding the value of c, and the last mark will come from actually answering the question and finding the nth term. I just want to add here that it is possible on this part here to actually find the second of the first difference, T3 minus T2, which was defined by 5a plus b, right? So just to go back here quickly, if you look at this here, is the second of the first difference, 5a plus 5b. It is always going to be like that. Now, even if we use this here we will then say the second of the first difference in this sequence is 10. So this means here I can write this as a 10, and here I'm going to have the 5, and then we said A is 1 and this is B. Remember that the A is a 1 here, and you can see that we are going to still get a B is equals to 5 here. So this also works. It's something that you can do. It is also true that you can use the third of the first difference, meaning if you say T4 minus T3, T4 minus T3 is the third of the first difference, and we know that we said it gave us a 7A plus B, a 7A plus B. Now let me go back again here just to show you what I'm talking about. If you take here the third of the first difference, remember this is the first difference, this is the first of the first difference, the second of the first difference, and this is the third of the first difference. If you take this, which is term 4 minus term 3, right? If you take this, you are still going to get be able to get the value of our B here. Now in this case, how we're going to use this, we'll say the third of our first difference, which is this here, T4 minus T2, right, is equals to that. So that means here you're going to write that 12 is equals to 7 times 1, which is the value of A, and then a B. You should be able to get the same answer. I want you to go try to find the value of B using this method, and be sure that you get 5. Check if you get the 5 as we have found it. I'm showing you this because, you know, it's very important in terms of answering certain tricky exam questions where they will start giving you one of the first differences there, and they require you to find other stuff in the sequence. So just be on the alert and be comfortable, not only to always depend on this. Be able to find the first, the second of the first difference, the third of the first difference, maybe even the 10th of the first difference. Be able to switch around those. Now I'm going to jump to question 1.3 here. I just wanted to emphasize that point because I think it's very important. They say here, now calculate the 32nd term of the sequence. We are looking for the 32nd term of the sequence. So here we are looking for, this is 1.3, we are looking for term 32. Now we already have our formula here, so that means if I come here and say term 32, what I'm simply doing is that I'm substituting this 32 because n here is 32, the number of terms we're looking at the 32nd term. So I'm going to substitute 32 where I see an n in our general formula, because remember, the general formula assists us to find any term. That's why actually we are asked to find a term in the far part of the sequence, somewhere there in the 32nd position. Now this means here I'm going to have 32 all squared plus 5 times 32, and we have a plus 6 here. Now this from here becomes very, 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 very boring, because you don't even need to crack your head. You can quickly just go to the calculator and find the answer. Now this would mean that at this stage I'll just pull my calculator to say I have 32 squared plus 5 times 32, and we have a plus 6 here, and this would then mean that our 32nd term would be given by 1190. And this question is only really for 2 marks, because what we are doing here is that we are going to mark the substitution and the final answer. Let us have one more practice of this quadratic sequence.